Okay, let's start thinking about square root functions, and we had talked about square root being the inverse of a square function. So if you took, just to remind you how that happens, a square function, and you did a table of values, you could plot this, and we know it looks like this, and we have values 0, 0, etc. Oh, and we're going to restrict it so that it passes the horizontal line test, so get rid of those, which gets rid of those, right? Now we can start talking about inverse functions. Alright, so when we talk about graphing the inverse, I had the point 0, 0, we had 1, 1, and we had 2, 4. And so if we went to an inverse function, I would also have 0, 0, 1, 1, and I'd have 4, 2. So that's out here. And the graph looks like this. Okay? So if you look at this reflection across that y equal x line, you can see how this worked a little bit, and you could see, you know, across this line I could go this way to get to the x squared function, or this way to get to the inverse. Across this line you go on either side to get to the inverse function or the function. So, but what we're getting at is this idea of the square root and the shape of that parent function, because this red line, whoops, I forgot to change back to red, this red line is your basic function f of x is equal to the square root of x. And we don't allow taking square roots of negative numbers, and so you see how, you know, restricting that domain earlier set us up for a square root of x, and the domain x is greater than or equal to 0. You could also, let's get a better picture where you have only the square root. So here we have only the square root function. The domain x is greater than or equal to 0. The range, remember, is the y values. So y is also greater than or equal to 0. You could talk about x and y intercepts. X int 0, 0. It's also the y int. Okay. And that would be our parent function. Okay. So you want to remember all of this when you're talking about parent functions. Now this doesn't quite flatten out as you go square root. You know, it's going to go increasing forever and ever. So this is a function that's always increasing. So let's talk a little bit more about domain of this domain of the square root function. And we had talked about you'd never take the square root of a negative number, right? So what you're going to do is, when you see a square root of a radicand, and the radicand is an expression under the radical system, then you're going to say the domain is anything is allowed except if the radicand is negative. So the radicand must be, let's do it this way, must be 0 or positive. Okay? So let's do an example. If you had the square root of x plus 4 is your function, then what would you say for domain? You would say domain is all real numbers, but then you're going to take the x plus 4 must be greater than or equal to 0, so x must be greater than or equal to a negative 4, and that is your domain. Now remember, we said the square root function was an always increasing function, so when you talk about range, your lowest value, okay, corresponds to that lowest value of x, okay? I don't know how shorthand for correspond. Lowest value goes with, how about that? The lowest x. Okay, so again, if you had the square root of x minus 7 or something like that for your function, you would go through and say, oh, Well, that's great. The domain has to be x greater than or equal to 7, right? And then you would say, okay, so what is f of 7? Calculate that, and you get 0. Okay, so that's your lowest value of y, so you know y has to be greater than or equal to 0. Why don't you try one? Find domain and range. F of x is equal to square root of x minus 2 plus 3. Okay, and that plus 3 is outside the radicand. Okay, you should be getting x is greater than or equal to 2 for a domain, and the range is greater than or equal to 3 for the range. Hopefully you're kind of looking at this and saying this is looking very familiar to like a vertex form. So we don't call it that quite the same. Vertex doesn't have quite the same meaning here. But let's see what we can do. We can go back to transformations, okay? So remember how we would look at something in this form where it would be h units to the right because the minus h is inside the function where the parent function is the square root, so that's under the square root. It's going to be a horizontal. The plus k is an up transformation, so we call that horizontal translation. Remember the a is for vertical stretching or compressing, and of course if there's a negative sign then we're going to reflect it across the x-axis. Okay, so a vertical reflection because that plus or that negative is outside the square root. Now, you notice we have this h and k, which when we were talking about quadratics was the vertex, but now that's sort of like the minimum values, okay? So what you can do is you can say domain, in this case is x greater than or equal to h, and the range y greater than or equal to the k value, okay? So it's very easy to get the domain and range from looking at this kind of transformation form. It's also going to make this really easy to graph. So say you had something like, let's do f of x is equal to square root x plus 3 and the square root minus 4. Then I'm going to go over here and I'm going to go, well, I know the parent function looks like this, right? But I'm going to take my function and I have to go to the left 3 and I have to go down 4, and I'll do the same shape from there. So go left 3, down 4. That's my new start, and I make the same curvy shape up and over. Okay? So it makes it pretty nice to graph it. I can tell you the domain is x greater than or equal to negative 3, and the range is y greater than or equal to negative 4. Alright, you go ahead and try this next one, and don't forget, make sure you change the direction of x, right? And the negative outside is the vertical, remember, reflection. Okay, so in this case I remember to go to the right 2 spaces, and then rather than go like it normally does, I vertically reflect it, so now it's down below the line, and then I move it up 1. Okay, so there's an order of operations that goes on here as well. So I have the blue line as drawn, and you can see how this is affecting the range. The domain is as expected, so we still have x has to be greater than or equal to 2, but the range has sort of gotten turned upside down because now we have y is less than or equal to 1. Okay, so with a negative sign you've got to turn that upside down.